Hello everyone. Hello everyone. Hello everyone. Hello everyone. Hello. Hello, everyone. Um, you're welcome to today's. You're welcome to today's webinar. It's an honor having you today. Sorry for the kind of hitch. We are starting a bit late. Trying to sort out something, but first, I want us to actually see in a different way where of what we are doing today is more like an expository aspect of getting things done in the aspect of design for manufacturing, and in this case for additive manufacturing or 3D printing, how your design, how we can work with the process of your design, and how we were able to get things done with a whole lot of what we are doing. So I want us to get into work now. And then first I want us to share something from starting from the beginning. First, let me introduce myself. I'm Felix Amaefule, Program Manager 3D Africa. So, and let's say product designer, design engineer, at the same time, Program Manager 3D Africa. I kind of refer myself as someone who has been in 3D printing or additive manufacturing for a number of years, and then with a kind of a practical experience in the aspect of how it takes prototyping and then product development. So I want us to first to get through the aspect of what we call manufacturing. It's because the essence of manufacturing is the so the essence of manufacturing is a case where we have formative, additive, and subtractive. I want us to actually look at things in this area. When we talk about at manufacturing, manufacturing has to come with trying to get whatever we have designed or whatever we have conceptualized and trying to get into, and then can we manufacture in the industrial aspect of manufacturing. We can have formative in the aspect of mold making and pattern making, and the other aspect of maybe plastic, call plastic molding, injection molding, and all that are all in the aspect of formative um, manufacturing. Then the aspect of subtractive manufacturing, most of us might have heard about CNC milling, CNC lathes, and some other like cuttings. The more of subtractive, any type of manufacturing that actually removes material from a particular base block. So CNC milling, lathe, and all that turn on operations, you will find actually get to find out this called subtractive manufacturing. Now, 3D printing, or synonymously called additive manufacturing, then the aspect where we have a 3D printer. One of these things, we have different processes of 3D printing, and then we have a where we add layer by layer. So 3D printing or 3D manufacturing in a more holistic name is adding that layer by layer thing. So you have a material, you can actually add maybe 0.5, 2 or 0.1 meter at each layer. So it's more like trying to build multiple layers of 2D. So we have like kind of a plane, placing different multiple planes as in going upwards, or so going upwards. So if you have your x and y on a table, and then you have the z axis going up, so you could actually have multiple planes. So it slides in such a way that you have multiple planes building up. So each plane is like 2D, but not having each topping up to make the 3D. So it's more like adding layer by layer. So that's what we'll get to find. So basically, when we mean what is 3D printing, more like a formative is a form of additive manufacturing. So 3D printing is like a form of additive manufacturing. So it's more, though today most people have synonymously qualified 3D printing as additive manufacturing, but 3D additive manufacturing goes beyond 3D printing. Because when you're talking about the pre-processing and the post-processing aspect, the heat treatment, the cleaning up, the trying to the priming, the painting, the aspect of the house, all these things that has to go with after even the object being 3D printed to actually get what we want is all round up to be in the aspect of additive manufacturing. So 3D printing is that process where you get an STL file or maybe a similar file and get into a printer and it gets to build out. But the post process and the pre process aspect of it, or you get to find is all encompassing in additive manufacturing. So it's a process of joining two materials to make an object. So from 3D model data, layer by layer process. So if you get to see the image here, just like a plane I already explained. So this box was built layer by layer, slides in different layers. Like maybe you can have up to 10 or maybe 100 layers that the box will slide. So what means that the 3D printer will move from one layer to another, or another layer to another. So when you finish printing the part of this layer, it moves up over the. So this is like going up is like the Z axis. This can be called the x axis, and this can be called the y axis. So going up at this level now, layer by layer, can be certified as the z axis. So you are seeing the build kind of going up from the bottom upwards. So and then when you talk about 3D printing, why is it one of the things that we'll talk about disruptive technology in the fourth industrial revolution? So why the noise about 3D printing? Why the so revolution? Why do people say there's a revolution in 3D printing? So these are the few benefits that 3D printing offer. They may be fast production, easy accessible, better quality, of some product manufacturer, tangible design and product testing. So, and the cost effectiveness depending on the quantity you want to manufacture, though. Creative designs are customizable, with customization freedom, unlimited shapes and geometry, can implement associated raw materials, less waste production. So, let me start from the less waste production. Like just like in subtractive manufacturing, we have to get the material, and then you get a material like kind of a block, and you machine the material, and then you have waste of materials, and then just to get a particular product. So you have in the process you're going to have a lot of waste of material just to get something. In 3D printing, you're having a lot of waste, a little waste. So the waste you probably are going to have is just your support, depending on the type of design, to have your support, maybe your raft and all that. So depending if it's FDM type of 3D printing. So this is one of the things that it can be cost effective. So for somebody to say 3D printing is cost effective, where the wasted of material, cost of material and wasted of materials can actually be part of the cost effectiveness. And then the aspect of time wasting, and then especially in the product development or prototyping, it takes a whole lot of time when you get to have a product tested from design, you get to have produce a mold or make a pattern, that process, and get to produce it first, and then so but with 3D printing you can just from the CAD file export to like maybe a format file like STL, and then you can send it to your machine slides within minutes, and then you can send to your machine, and then you get to have within few hours depending on the size of the product. You could have something that you could be like kind of a first consumption kind of a product, or what is prototype, sorry, let me say product, where you can feel and make more detailed analysis and more communicate with the product and see how you could improve the changes that come for it and all that. So faster production. So further production means from the point of the conceptualization to the point of having maybe a functional product, you could actually 3D print and actually bridge that almost 30% when compared to like maybe more compared to processes like subtractive manufacturing or formatting manufacturing, especially in the mold making and the pattern making. So these are the things that there's a lot of things that 3D printing offers. So first, I want us to actually understand the flow that 3D printing takes. 3D printing gets a kind of a file. So you have a model design using 3D CAD packages, probably just like we were talking about today, such as Fusion 360, either through the normal parametric modeling or is even generatively designed. So, like, we'll probably make mention of generative design in long run, a later stage, but just bear in mind that it could be generated by parametric modeling or even from sculpting modeling, or sometimes it could still be generated from 3D scanning, or you can actually use generative design approach to get to generate the CAD model. And the models are designed in 3D and then exported as an STL file. So it's very important that we understand that the CAD format for, like, if it's Inventor or an CAD file like Infusion or SolidWorks or any other softwares that you can actually use for 3D modeling, or what we call 3D parametric modeling software. So after that, you have to actually export it to a particular format where the slicer will begin to understand the format. So STL is one of the five format that is most popular. So you get to it. So the STL files are, so now getting to the STL files now, the slicer will now get to read the STL files and slice these files into layers and send to upload into the 3D printer. So what the slicer does is to actually slice. It still uses the same kind of mechanism of your computer numerical control CNC, and maybe CAM, computer aided manufacturing CNC machine driven. So it still uses that same of G code and all that. So 3D printer has actually kind of uses that as its coding of G code. So it gets to slice that the 3D model, especially the STL file, to slice it layer by layer, just like we found out in this area. So that's what the slicer will do, to slice it layer by layer. So layer by layer on all this. So the slicer will be able to slice that depending on your configuration. So you get to slice depending on the configuration of your slicing and all that. So you could have slice maybe 0.1 mm or 0.2 mm or 0.4 mm depending on what you want. But the more you increase the thickness, slicing thickness, the more you actually get to lose you get to find visible lines coming out, and then you will not get a final finishing, but you will get a faster print. So depending if it's your first conceptual design that you actually want to look at thoroughly more, so you can actually use something that is faster and all that. So but if you want something that kind of functional prototype, then definitely, or something you actually want your customer to get engaged, then a final slicing layer thickness will actually go in. So the other aspect is the 3D printing. The 3D printer, the 3D printer then prints the STL file in layers. So it gets to print it to and fro, gets cut the 3D printer for each level. So you keep building up to, and so now at this point in time, this is like a drawing that was done in Fusion, and then so that's the digital design. So done something with the 3D, the digital fabrication now, how to create a 3D model to 3D print. So you have a digital design, which you find in the image here, and then you have the slicing, which you could use depending on the 3D printer you're using. You have 3D, you have customized 3D printer for a particular brand. You have an open source slicing for open source. There's some 3D printers that can actually use like open source slicer, and then you could have like MechaBot. You could have like a MechaBot slicing software. So to slice a product for MechaBot 3D printers. So and then after the slicing, you get to prepare the file and put it in the format that 3D printer will recognize now, and then you get to turn it into a real physical product. Get to print and then turn it into a physical product. So the next thing now, this is a kind of a case study. So this case study was a student that did something this way. So now this is one of the things that 3D printing does. Actually, like I told you, as I made mention of prototyping from the conceptual. So there are a lot of iterations that goes in before in between product development. So this is the first design concept that this young student was prepared, and then this was when the 3D printer was. So the low plastic aspect of these things were 3D printed, and coupled even the blade inside and all that. Then the switches was just bought to fixing. So and then so you have the in between these you have two product development. So for the sake of not taking time, so about here we could actually use generic design. It gives you varieties of a lot of solutions, and you can choose the one that get to meet your your need. So you have innovative design options, lightweight, because of it could actually organically generate. So it could actually add materials where it's necessary and not just adding materials for the sake of, because there are some of our designs we just add those materials are there just because they are parametrically designed. So but and then parts consolidation. So how do you get to look at lightweight and look at the strength? Sometimes you could your 3D printing generative design models could even be more stronger and resist stress than that of the parametric thing. So because it actually considers stress load, because we already added stress load, possible places where stress load could add, as if we are running FE analysis. So we already added those stress load so that the and then telling the system to generate something that could withstand this type of stresses along the line. So it's something that goes a long way to help out in um in getting things done and in the way we get to design. So then the generative design and 3D printing. For me, it's I call it the manufacturing of tomorrow. So that's so combining the generative design and 3D printing. It's something that has so much huge benefit and so much huge the, that definitely will change the way we look at things and the way we do design. So for now, generative design is a new product, also to say in engineering. You get to have it in Fusion and some other product vendors outside Autodesk. So not many have actually appreciated or adopted the generative design, though it's still having its own constraint because most times it's limited to 3D printing. But with newer solutions, generative design is actually where you could do machining, you could do die casting with some of the products here that you generate from generative design. So so let me get to explain what generative design in a more better way. So generative design software helps to conceptualize parts with complex organic shapes, just like I said there. So you will have complex parts and then very organic shapes, unlike the parametric shapes that are inorganic shapes that I have to meet in a straight line, you have to meet this curve, a particular radius and all this. The organic shape does not follow those sequence. So you could actually generate something that looks unique and looks organic, like looks natural with generative design. And because that 3D printer has the capacity to 3D print something in organic form, organic shape, and at the same time something that is very complex, then it's like a match for it. So with 3D printing, you could actually do a lot with a generative design shape. So 3D printing, on the other hand, is perhaps the ideal technology to bring these shapes to life, since it is not only capable of creating complex geometry, but also does it cost effectively. With traditional manufacturing, producing these shapes might often be impractical, if not impossible, either due to high costs or limitations of the technology, which 3D printing is bridging now. So, however, it will be misleading to state that design is limited to only additive manufacturing, although in many cases, the technology will be most optimal production method. With some generative design software packages, you can specify manufacturing method like CNC, machining, just like Fusion will have. You will have CNC milling, you have die casting, you will have the additive manufacturing and one other method of manufacturing, so that what you generating like injection molding. So what you're generating will be in a situation where it could actually the shape could be manufactured by the method of manufacture you have selected, just like that casting or that or injection molding, in addition to additive manufacturing. So now this is something that is done for generative design. So in here now, this is like a 3D parametric design. So just like a normal thing, you just have to you have designed some. So you look at the materials and then looking at where the forces are acting and what the usefulness of this. You should see these are the points. This point here, here and here, and then you are having these places connected. So but you are now having a large chunk of material being there, so the weight is too heavy. So if you're using this design, so you see there are a lot of weight in here. So and then if you're looking at designing for something of light light component or a light system, then this becomes a thorn in the flesh. And at the same time, cost of material. So because of the cost of material you're going to use, this is already on the high side. So and then there's a lot of things that comes in now. So but now you can actually use additive manufacturing to generate something that could do exactly this and can still be uh, um yeah, it can be look complex like this, but at the same time look, you can have stronger materials, you can have stronger parts, at the same time have reduced cost because to intercept and all. So there's a lot of things that will go in there though, but this is like a kind of a concept of how it could all drive. So now for the generative design, so for 3D printing, you could have more 3D printed objects. Example, so in 3D printing, you have a lot of application in construction. So getting this is a house that is 3D printed. So you get to the wall that the printer. This you can do that in a matter of hours. So this is like the type of 3D printer that is driving this. So you're having a 3D printer that is actually having concrete book sheeting and this is layer by layer. If you look where you will see is having layer by layer depending on the layer size that was actually used to configure a 3D printer for this. So you're actually seeing this 3D printed. So it's crazy and it's awesome, so to say, that you could actually have in a low income communities build houses in matter of hours, like like a matter of hours, and people start living in it in matter of a few days. So it's something that is unique and is awesome. So this for construction, you can have that a lot of things there in ornamentals and fashion. So there's even 3D printed food now, like chocolate, like cake, and all some other food that you can actually 3D print. So you have 3D printers that do that for food or ornaments or things, lightnings and all that. So 3D printing can come in different areas and different applications. So this is just like maybe in the mechanical aspect of the whole thing. You have 3D printers. These are all 3D printed. Then so for now we'll go into kind of live demonstration on the fusion. So I want us to have kind of a feel of how fusion could actually get to how we could leverage on fusion and how would how we could take advantage of fusion, the power nature of fusion. First, I want to say something for every single person that's going to watch this video, that's watching this video. I would love to advise that you get acquainted with Autodesk community, ambassador community. So it's very something very important. You can actually type Autodesk ambassador community because there you will actually get to find student professionals that are actually using these softwares, and then how you can actually learn more and have so much to gain. Definitely, there's so much to gain. So let me go straight to the fusion here. So I will first trying to explain this is fusion, how fusion works, the interface. Probably most of us here have not really get to appreciate or get to use fusion before. So this is Autodesk Fusion 360. So we have our models here, like the interface, like kind of the tabs here and the panels here. So you have our data panel. So we could have a lot things we are drawing. So we have our account here where we could get into our this account or sign out from this, and maybe we can sign out with another Gmail that have Autodesk license already assigned to it. And then we could at the same time, so and then this is like a workspace. So we have the design workspace, which is where we are. We have generative design workspace. So this generative design workspace is all available when you are having a professional license or you are having a, it's like this is education license but using a school domain, a school email domain. So if you're a student and then you have an your school gave you email address school with school domain, then definitely you could use it to access for free. You could use it to access through the printer. You have to use this particular thing, so I will tell you the education license with this. You could actually use it since the most of the people watching this video are more of students. So that's how I get to log into this, so I will get to actually understand. So this is your renders. You can actually do advanced rendering. You could do simulation in there. You could do your manufacturer, which is like a cam, your two axis, 2.5 axis milling or even turning operations. No, that's so. Let me just go to the aspects of the I'll switch into the manufacturing aspect. So you get to see the 2D, the turning operation, the additive aspect, and then under the turning operations, you get to find sort of turning operation, drilling, and all that. So milling aspect, you get to find the 2D, 3D, the multi-axis, which is like the 3 axis plus 2 axis. That is kind of a 5 axis milling or 4.5 axis milling and all that. So in the aspect of fabrication, you could actually get to have your cutting, manage your files, get to generate your G codes and all that that you're actually going to use to send out to your CNC machine. So in generative design, let me not go there for now. So so in your design, Inventor has Fusion 360 has a kind of advanced rendering capacity. So most times your rendering capacity and rendering quality could still determine how you advance in with rendering, and then but it actually gives you that capacity so you can actually have super rendering because you can leverage on the cloud rendering capacity from Fusion. And I want to point out something here. Fusion 360 is like a kind of a actually runs in cloud. So your data you save, you actually saves in the cloud. So like if you have these are projects or these are all sample projects, and then you have projects here. So I could easily get to create projects. So I'll come back to that later. But your projects here, the software runs in cloud. So it's connected. If you check here, you get to see that I'm actually online because my internet I'm actually working online. So you can actually work offline, but at the same time you can't create projects. You can't create projects, you can't create new folders, and you can actually save your projects really because you can just only have it seated in your software, but it's actually not in your cloud where your main storage is. So, and there are a lot of things, the collaboration aspects where you could do commenting and all that, you can actually do that because you have a lot of, because you are actually offline. So okay, let me go back to okay, our design here. In the design, with Fusion, you can actually do sheet metal. You could do surface, that is surface modeling, like the surface modeling and stitching. Could do 3D. Then in the side is solid, you could do the normal parametric design or you can do sculpting by creating a form. So you could do a lot of sculpting these things. So sculpting is actually use sculpting to generate maybe product that's actually very difficult. Design actually is very difficult to use parametric workflow for design. So you can actually use sculpting to actually modify how they as in create the object and create complex shapes. So you could easily use sculpting to create complex shapes and then convert it to a 3D model and then continue working on it as if it's a parametric generated model. So that's for that. Let me not go spend so much time on the introduction and then so but one thing there is how with 3D printing, as in how does 3D printing and then additive manufacturing gets to work hand in hand. So if you actually have a product here, if you have a product which I will maybe trying to sketch out something as fast as possible, so you could actually generate or export your product to STFIs easily from Fusion. So you could come here on the new design. So you could come here and then we get to see export. So under the export, you could do sorry, not export, sorry, under the 3D print. So under 3D print or save as. So in under 3D print, you could actually use export to STFI. So you get to have this. Um, you get to have this like your refinements and all this in preview as a mesh. That is if you have a product, and then you could actually get to have your utility. So if you're using utility print, so this you can actually use it to work on the mesh. So like Mesh Mesa, 3D Printing Studio, and some other things. So you could get to work on some of them like Mecha Bolt Replicator, Slicer. If you have a slicer, it could actually show up here. So you can actually export, and then as you are exporting to 3D printing, it's openly being opened by the software itself. So I will talk more. I will really get to say this in respect to 3D printing because of that's why the we are looking at in the design aspect and how we actually get to do with 3D printing. So So now you could actually go back here and then say under save as. So actually you have not actually saved this. So that is the thing. So if I actually get to save this as okay, okay. So if I say save, could retrieve the data and then save the document. So let me say 9. Sorry. Okay. Yeah. New project, or I could create a new project from there. If I have not created a new project, so I could click here and say new project and say not the project, I call it let me say 9 key. Then click here, it creates the project. So it's actually creating the project, and this project is actually being saved in my server. So in my local in my, not really my server, what I would call it, in my Fusion directly, which is hosted online, and I can access this this project even with my browser. So I could access this with my browser. So with this nine making, I could create a project, a new folder inside the project and call it uh, um let's say webinar. So you will get, we're going to say, so yeah, as I have this created by and I can save now, and then I have this saved, and then if I come back here, you can find the project I just created. Now open it up, you will find the webinar inside. So it's a file, and then we are having this file inside the webinar. So that's basically where this is saved, I think. Yeah. So let me get to say save as, and let me confirm something. Okay, so there, that is it. So okay, it's actually saving up in. Let me get to pull it here, then make sure it's saved inside the webinar. So I have this. I can go back, pick up this. So let me delete this. So because what I saved here before was saved under wrong directory, so I wanted to save it inside this webinar so that I'm having the right thing now saved here. So this document has been saved. So I could actually create folders here. I could actually upload, maybe you did a work in SolidWorks or Inventor or some other modeling softwares. You could actually upload the softwares and it translates and appear here. So you could actually create components outside and then upload them here and then kind of combine them. So and then for some of us who might have used AutoCAD, maybe or SolidWorks or Inventor, so it's the environment here might be a little bit confusing because of how it's all structured. But if you get to understand it, it's something straightforward, very very straightforward. But the only thing there is you have your browser, you have your timeline, So when we create, as far as we selected to capture our timeline, so say as far as this is not, we didn't select this, so it's actually going to capture our timeline. Then we have the viewing, have our view cube here. So and you could create, this is like a really like kind of component. So we could actually create sub component, and automatically this becomes a kind of an assembly. Then we can still do this as if as a part. So depending on how we structure our work. So and then it's just one interface. So unlike SolidWorks or Inventor, where we have to design some parts in different permanent parts and then bring them in assembly. Like we could do a lot of great things here. So we could design from the one file and then create parts on it and then build up immediately. Or we could still design it as part, and then create another one and could call assembly. So it's a great thing, like a great tool, straightforward. So let's say we want to create something simple, and then I want us to actually drive into the parametric aspect of our design. So how do we get to use parameters to drive our design? So I want to pick up a sketch now. So but make sure, let me say this, make sure you check here and then get to, you can select your diameter for this document, whether it's centimeter, meter, inch, and all. Let's keep it in inches. So okay, let's go back and create our sketch. Maybe you can pick up sketch here. Okay, let's say pick here. Then what exactly do we want to create now? So okay, let's just create something very simple. Yeah, let me just create something very simple that we could get done here now. So I get to this point. Let me use here. I always advise you to use your origin. That's your, let your base sketch make reference to your origin. It's something very, 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 very important. It's very, 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 very important that we make use of our origin. So it's something very, very important so that it makes our sketch stable, so we can actually make reference to it. But the major thing there is makes your sketch very, very much stable, and it actually most times applies automatic constraint to it. So okay, so I pick a sketch here, so I could easily pick up here. I could just, usually we are just sketching, we are not drafting, so we could just draw something that looks like it. And then later we'll use our geometry constraints and then our dimensional constraints is mentioned here to actually get to dimension our work. So okay, I can pick here and then draw a circle here, draw a circle here. Now I want us to, one of the things I want to achieve with Fusion now is how can we use Fusion to actually drive with kind of equation, integrate equation to our design and how to do design intent, how do we capture design intent and predict how our sketch or in perspective our model, how do we get to react, how do we can have our, so when there is changes, how will our sketch or hand and invariably our model, how can it actually get to react or readjust? Is it actually going to fail, or can we predict how a particular change will affect the drawing? So if we're able to capture that in our distance, so it makes our we being in charge of our design, so that we don't just a little change and then we are mad, like everything just goes down as if you are all starting afresh. So starting your sketch and then being intentional about it is something very, very important. So I just want to create something, and then if you see that I want this circle to be equal to this circle here to be equal to this circle. So but that's not really what I'm looking for now. I just wanted to dimension here from here to this point, and then I want to have a uniform thing. So I want to use this circle to drive this. Seriously, that's what I want to do. So and how do I get to achieve that? I want to achieve, so I get to pick this up and I dimension this and then say it's okay. Okay, let's say I want to use 70, so I say 70 millimeter. But okay, so diameter 70 millimeter, and then I say from here to this point I want to use, so the kind of the distance between that I want to use 30. So invariably what I'm trying to say is that always that from here to here, so that will now, you see that if you actually notice, let me undo. So if you actually notice this now, if I get to put 50 here and press enter, I see this update. So I can actually use it to drive that thing. So and then now I could do something a bit crazy now. So like I know it's for some of you who are starting in CAD, it could be a bit crazy. But that's actually the best way to go, especially integrating equations to your drawing and to your parametric table, which I will get to show you later. So whatever we're doing now is actually being reflected in our parametric table. So okay, okay, let's continue. So with this now we have 70 as our diameter, and we have from this distance to this distance as 50. But I want to have this as 50, and I want to have from here to here to be equal to this. So when I drive this, or okay, let me say I want to have this as 100, and I want to have this to be always half of this, will always be half of this. So I can say 100 here. So I type 100. So I'm trying to integrate equations now. But I said this. So instead of typing 50, which is half of it, what of it tomorrow I type 70 back? We have to come back and change this. So well, how can I write an equation, integrate an equation, something very simple that could actually get to help me change this, as in help me update this whenever I update this. So with this now, I could actually click on this dimension. So it's D1 as assigned to it. So I can say D1 divided by 2, something simple, right? So we have a 50. So we are now having the parameter table fx trying to actually drive. So funny thing now, if I get to put this 80, you will see this will turn out 40. Cool, right? So it's something that we could easily get to drive. Very simple and all that. So we could now, I can now come back and say using geometric constraint, and then click here and say I want this to be equal to this. It updates on this one. Yeah. So this, so and then what does it mean? So if I get to now change this to 100, everything changes, right? Cool. So with this, what I just did now, so I could just trying to use one parameter to be able to drive the rest of the thing. So now I could say that since this is 100, let me say from here, this is 100, this is 100, let me say 3. So I want this to be like 300. So like 300 now, but I want this to be like, since this is 100, I'm looking at 300. So I want this from here to be 3 times this distance. Does it make sense? Or 4? It should be 4. So well, 4 times this distance. So if that is the case, so what I will do, I pick this up and say this here and this here. I pull it out. It seems to be showing me, yeah, almost 5 times. So with what I have here, so I could say 5. So I say D1 times 5. Oh, cool. So it gets to update. So if I get to change this now, one good thing there. So I'm using this one parameter to actually drive this, and even drive this. So if I get to change this back to 70, you get to find this update 350 now. So basically that's the equation. So you could have more complex equation in being integrated in your work, but it does a lot of things for you. So come back here, and then you go back to the parametric table. Yeah, go back to your parametric table, and then go to modify, go to change parameters. Then I could drive in, could get to model parameter, go to the sketch here, and then I'm having this. So this is 70. So I want to create a user parameter that I'll have to name, that will be different from like, it's not attached to the dimensions I have, but I can use those parameters to drive the dimensions that I have created already. So the D1, D2, D3, and the rest of them. So if you can find here, you will see this one are all written by the equation. That is the one that I'm using parametric, but the other one I used geometric constraints. So whenever this updates, it actually drives it by geometry, because I made it equal to without applying dimension to it. So I could say this is now, I could call this length, slot length. Let's say slot length. Okay, slot length. So is a millimeter, and then I could say is a expression. Let me call it 100. So I could actually write an equation here to actually drive it if I want to use. So that's the expression aspect of it. I could drive, and then it gives me the value here. So the value is actually going to be regulated by reference. So I can type direct value, numerical value, or I can have an equation here to drive it. But this one I actually want to be using, to be typing into right. So yeah, let me just leave the comment. So since my name is actually showing something descriptive. So I add it here. So I have here now. So I could come back here and say at this point in here, I don't want it to be 70 mm. I want it to be driving. I want this slot length now to be driving this. So I can say type slot length, yeah, pick it up here, and then cool, right? So look at what was going to be happening now. So with this I have just did now, you see that I could, so if you come back here and say no, I want 50, it changes, and every of the values I have here changes. So it's 50 here. So because I type 50 here, this changes. So if I type 60, this particular place will change. So 60, it changes because it's not driving. So this is the expression, this, so, and then everything is changing. So if I get to type here from the table, and the same way that our sketch is changing, get to type back 100, you get to find out, enter. So you get to find out that this changes, this changes, this changed. So and then the same way our model is changing without giving us error. So these are the things that we will get to understand how our design work, and then how we could kind of integrate some of the things we want to do. So okay, so we could not say okay, we want to pick up this, and then pick up this, and then okay, and we sense no solid. Okay, fine, 10 millimeters. Yes, 10 millimeters. So 20 millimeters, and then so okay, so new table. So when in the extrude, you're actually going to find the operations. This is because we don't have a, this is our first model, like our model feature, 3D feature here. So it's actually select automatically new solid. So this will naturally make sense. But if you actually want to create this as a component, you could select. But the join and all those things will not make sense here, because you are actually, you don't have any 3D model already, or 3D feature that you want to join these two. So let's say we are creating it as a component now. So we want to create this as a component. So I can click here and make it as a component, right? And then so it's actually going to be saved as a component, as a new component down here now. So if I click OK, so I have this component one. Cool, right? I have component one here. And then this automatically has turned to be an assembly now. You get to see that something changed here. You see it was part here showing on like kind of a part. But immediately I created a component and added the component, it changed into component now. And then change the kind of assembly, kind of building, and then you have a component inside, which is like a part now. So it's pretty cool. And then I can still go back to my parameter table and say, okay, now I have instead of saying 10 here, instead of saying 10, so in the component now I could say extrude, and I have 20 extrude one, so I have 20. So instead of saying 20 millimeters, I could say is equal to half of this. So one fifth of this. So I could say this is equal to this, right? So copy, say this is equal to this divided by 5. I'm good to go, right? So it doesn't change because that is 20 is something with it. So now if I go back here and drive this back, so if I come back here and try and say, oh, this is now 90, see this changes, right? So cool, become from 20 to 18. I come into the explaining that before I start explaining into those communities, but I could easily get to explain some of those things in the community. So first, let me go to the browser and then have a situation here now. Let me say it is an academy. Um, So okay. Let me go to the point where I could get the result of this the design academy. I don't have it offhand, but let me get to find it out. I could just go. Okay, let me Google it so that design academy. Just Google it so that all of us could actually get to follow that link. So there's design academy. So if you get to type it, it's going to show you up in the okay, coming up. So you have this Autodesk Design Academy. That is academy.autodesk.com. So okay. So okay, first in the aspect of let me go to the Data Design Academy so that I show you how you could sign up for to having an Autodesk, creating an educational Autodesk account. So very important so that you could actually use as students could use it to sign up for Autodesk softwares and that is have about 3 years license for some of the Autodesk software like Fusion or subscribe for Fusion or even Inventor and some other Autodesk products. So in here now, if you are signing, you could click in here, join today. With the join today now, clicking on join today, we actually get to give a form to fill. So in this form to fill, you will get to do not Autodesk education account. Don't click on Autodesk professional account, please. Just click on Autodesk education account, and then under here, under the Autodesk education account, you find sign in and then create an account. You will actually create an account because you don't have an account yet. So click create an account, and then you will find the country. So you can check Nigeria. Go here, pick Nigeria. Sorry, okay, Nigeria. Education role say student, institution. I know. Let me say institution. Yeah, university or post university. We say okay, January. You have date of birth or what have you. Let's say okay. Sorry, maybe this. Then you click next. So you could just freeze it and then you put your full name, your email address, you confirm, and then you create account. Right? So you could do that and then you could easily create account and then it might ask you of your school. But when you do that, like you could, if you don't get to find your school inside, then you could easily get to type your school and add it up. So because sometimes it will ask you your school name and all that. If you create this account here as this account, so you could actually get to confirm your email. So you could go to your email address and they will send you an email notification, your email address. You get to confirm your email address. With the confirmation of your email address, and so you have Autodesk educational account. So with that Autodesk educational account now, you could easily come back here and say type in your web browser again, Autodesk education license. Let's say so. These are some things you could do to the Autodesk education license, right? So with Autodesk, you type this in Google, you could find free Autodesk software or downloads and all that. So this is a web link. So click here. So now clicking on the account will give you can have Fusion individual license, right? These are free license on the education. So you could have Inventor, you could have Revit, you could have some of the software. So let's say we are getting Fusion, which is one thing. So you're actually going for individual license. Unless if you want your school, if maybe IMAKE wants maybe engineering section and all that wants to have that. So you could actually reach out to that so we can find a way to there's a country manager and all that to find a way to how we could help deploy that in school and what it needs. But that is possible but for you as student, you just need to get it as an individual license. So click on getting an individual license. and you go straight, and then allow you. So because you have an account now, because you have an account already, so you have to have and then you have an account with this account. I still have an account on Autodesk Academy, so you could now click sign in. So clicking sign in, you could click on sign in, and then still loading. So clicking sign in, you could actually sign in with your details you have confirmed. Remember, let me say, let me just use this. Let me just use the sign in. Okay, so I have succeeded in signing in now. Okay, so yeah, it's still loading. So this is finished. Uh, yes. Yeah, so then it's signing in now. So the signing now, sorry, it's already telling me that you have already obtained access to this product. So I have already access to this product. So there's no way I would say, but with the sign in, I could actually get to create access. So it will tell me that you have obtained access to this product. So because of we mainly get to sign in here to tell you have obtained access to this product. So that's basically what you need to get, and then you could now click here to download maybe a startup file for the software. Click here to have a startup file for the software. And another area you could go now is type manage.autodesk.com. Right, so manage.autodesk.com. So you could actually use there to manage some of your softwares. It's like kind of a back end for your softwares now. So yeah, so it's a lot of things. So you could download and then install Fusion. Fusion, and then when you install Fusion, you need to be online. We're installing Fusion because it's going to stream the software from the startup file and then download Fusion and install it. So you need to be online, very important. And at the same time, after installing Fusion, you need to sign in with your email and your password you have inputted. That email, that particular email that you have used to create in the Design Academy. So, and then you could come here, come back here and check the softwares that are actually part of your that you have access to. So you could have more access to more than one software with the same email, but you will not. So yeah, that's basically that. So okay, I think they are running maintenance on this site. So now the next thing I want to talk about is under the aspect of the Autodesk Ambassador Hub. So here the Autodesk advocate.influtive.com. So click here, you could log in. And so I advise you to join this community. Click on this and then get to register, fill in the thing, ask questions, participate, grow your participate in the activity, get to become an Autodesk ambassador, or advocate, and then at the same time, because there are a lot of things, you can get vouchers, certification vouchers for us, also certification exams, like Fusion for Fusion or Inventor or any other software that or photo days that has certification. So it will go a long way to help you out. So please, I think this is slow. Okay, but okay. So I think it's up now. So it's very, very important that you could. So I have a personally I have an account here. So as a professional by a student, only going to meet people, a lot of persons down here, and then you are really going to you're really going to learn a lot. Learn a lot. Yeah, network with people, meet people, and then yeah, have resources and how what the trends, questions people are asking, and the explanations and all that. So it's like a forum, and then you get to find a lot of things still loading. So this is basically I'm just trying using this to run this up. So in case you have a lot of questions, you could actually type letter, or maybe you might have to reach out to me on let me type it here. Let me get to my notes and type it here. So if you want to reach out to me for question or for clarification, you could let me say this. Okay, you could reach out to me on this email address. I will try as much as possible to respond as I can. as time permits me. So yeah, okay. So basically, this is that. So you could reach out to me to this on his email, and you're cool. So I thank you for trying making it out for this webinar, and then it's something that as a student personally, I wrote my first three certification exams. I wrote it while as a student before I graduated. So it's something that you could do. I know something like designs and some of these things can be overwhelming, but it takes time, and for you to actually be part of this or come across these videos means you have the interest, and I encourage you to always push it for hard. Look out for people. If you find it difficult, reach out to people that will help you. It's something that nobody was there from when day one. So don't feel shy to ask questions, or don't feel shy to say I don't know and you want to know. So I encourage you to always explore opportunities to learn and learn, relearn, and then learn, unlearn, and relearn. So that's loop is something coming up. So always look out for more opportunities to learn, and then get into look out for opportunities to practicalize, and then there are a lot of opportunities out there in Nigeria now developing, coming up for design engineers. Actually, it's coming up like rapidly, and then even the workforce is actually smaller as in is compared to the opportunities out there. So if you can actually get to understand how the design works and get to master it, become a product design engineer or product designer, there's a lot of opportunities out there. So thank you for making it, and thank you for watching the video, and thank you for being part of this. Um, I'm so happy and grateful for being your host today. Thank you.